Good morning, or maybe I should say good afternoon. Today we're going to talk about Lesson 66, and Lesson 66 involves complex fractions. Now, complex fractions are really not that bad, and when we get done you'll recognize them immediately, and it will be very easy for you to do them. A little bit of vocabulary. Complex fractions are fractions that contain one or more fractions in the numerator or denominator. Here's an example. 3/5 over 2/3, 25 2/3 divided by 100, 15 divided by 7 1/3, and A over B divided by B over C. One way to simplify a complex fraction is to multiply the fraction by a fraction that makes the denominator 1. Well, that sounds really complicated, but it's really not. Here's an example. If you look at this, 1/3 over 1/3 is 1, right? And 3/2 over 3/2 is 1. So if I'm multiplying a fraction by 1/3 over 1/3, I'm not changing the value of the fraction because I'm just multiplying it by 1. But I am getting rid of, or will get rid of, the denominator. And let's see how that happens. Here's a good example of a way to solve a complex fraction. 3/5 divided by 2/3. Well, if I multiply the denominator by 3/2, which is the reciprocal, over 3/2, I get that well-chosen 1. So that I end up with 1 on the bottom because these all cancel out. Okay, and I end up with 3/5 times 3 over 2 on the top over 1, or 3/5 times 3 over 2, which is 9/10. Okay, here's another one. And these you should write in your notes because this will be helpful for you when you're doing your homework. 2 over 11 divided by 2/5. Multiply the bottom by 5/2 and the top by 5/2. Then you've just multiplied it by that well-chosen 1. Equals 2 over 11 times 5 over 2 over that 1 that you got from multiplying these two. Okay, and then you end up with 2 over 11 times 5/2, which ends up to be, when you cross reduce the 2's, 5/11ths. Here is another one, and this one starts out with impropers, because you have to take the mixed numbers, change them to impropers, then take the impropers, set them up. What is the reciprocal of 4/3? Well, that's 3/4. So multiply the whole thing by 3/4 over 3/4. The bottom reduces out to 1. The top is 14 over 5 times 3 over 4. And then you can take out a 2 out of here, and you end up with 2. And a 2 out of here, and you end up with 7. And so you end up with 7 times 3, which is 21 over 5 times 2, which is 10, which is 21 over 10, or 2 1/10. Now, have another one. This is another, and again, these are examples that I want you to put in your notes because they're different. This one's the whole number 3 divided by 2 1/4. So the fraction is only in the denominator on this particular one. But I'm going to go ahead and set it up this way. 3 over 1. I put 3 over 1, so that fraction. And then I took this and turned it into an improper. Multiplied it by 4/9 to get rid of the denominator, and of course you have to do the same thing to the numerator. So you end up with 3 over 1 times 4 over 9. You can cross-reduce. Okay, I'll move that so you can kind of see. Cross-reduce the 3 out of here. You get 3, cross-reduce the 3 out of here. You get 1. 1 times 4 is 4. 1 times 3 is 3. And you get 4/3, which reduces to 1 1/3. Okay? Now, here is one more example. Okay, 22 over 3 divided by 100. Leave this 22 over 3. Change this 100 to 100 over 1. You're going to multiply by 1 over 100, top and bottom, to get rid of this denominator. And you have a 22 over 3 times 1 over 100, which ends up to be 22 over 300, which reduces to 11 over 150. Now, I probably could have taken the 2 out of here and the 2 out of here. I didn't in this case, but I could have. Okay, now once in a while we are asked to change percents into fractions. And this is a way that you can do that using this method. So, let's say we wanted to change 28 1/4 into a fraction. 28 1/4% into a fraction. Then I would have 28 1/4. I'm going to divide it by 100. So I end up with 113 over 4, which is just simply making this into an improper, over 100 over 1. Multiply the top and the bottom by 1 over 100 so that we can get rid of that 100 in the denominator, and we end up with 113 over 400. Now, using variables only, it sounds kind of crazy, but once in a while you kind of need to look at this. We have a over b divided by c over d. A over b divided by c over d, multiplied by the reciprocal of c over d over itself. So we end up with d over c, d over c. This is that well-chosen one, okay? And we end up with a over b times d over c all over 1, because this cross reduces out to be 1. And your final is a times d over b times c. And that's using variables only. Okay, now, there is a second method which you might be kind of familiar with, and once you see it you'll go, oh yeah, I know what this is. This is also a method to solve complex fractions. So when you see a complex fraction, you actually have 2 ways to do it. Okay, so we have 4/5 over 1/3. This can be written as 4/5 divided by 1/3, because this little line right here means divided by. Okay? 4/5 divided by 1/3. 4/5 divided by 1/3. Does this look familiar to you? It should, because we have solved a whole bunch like this. Okay? Then, of course, we use keep, switch, flip. 4/5 times 3 over 1 instead of 1/3, because we have to flip the second term and change the middle to multiplication. And guess what? We end up with 12 over 5, which is 2 2/5. Here's another one. Same thing. 3/5 divided by 2/3 can be written as 3/5 divided by 2/3, or 3/5 times 3 over 2. 3 times 3 is 9, 5 times 2 is 10, and you're done. Pretty slick, isn't it? Yeah, great way to handle complex fractions. It really is. I will tell you this. No matter which way you do it, both methods do work. Here's an example of using both methods and getting the same answer. Here's 15 over 7 1/3. 15 over 1 divided by 22 over 3. That's just changing this into an improper. Multiply the top and bottom by the reciprocal of this. So this ends up to be 15 times 3, 1 times 22, which ends up to be 45 over 22, or 2 and 1/22. I go over here, do the same thing. 15 over 1 divided by 22 over 3. Keep, switch, flip. Keep the first term, switch the multiplication, flip the second term. 45 over 22, 2 and 1/22. The amount of work is just about the same. It just depends on which way is more comfortable for you to do it. Many of you will probably go with this way because of the fact that you're familiar with it, but it doesn't make any difference. Okay, now, your challenge problem is this. Do this division problem right here, both ways, using the first method I showed you and the last method I showed you. Okay? You must show your work using both methods to get the bonus. So you have to find the result using both methods, show the work, and you can get the bonus. Hope that's helpful, and I will talk to you later. Thanks.